Section 5.4, matrices. We've already been looking at matrices in section 5.2. We've been solving them, so hopefully this section is not too bad. Formally, you represent a matrix by an uppercase letter, and a matrix is just an array of numbers. Again, we've seen many augmented matrices already. The entry in every matrix is defined by a row first and then column second. So for example, if this is my matrix, let's say this is matrix A, and I wanted to know what the entry would be equal to in the 1, 2 position. This would be the A sub ith jth entry. So this means, looking at this matrix A, that the entry would be in row 1 and in column 2. So row 1, column 2 would be 2. Let's do another one. What about the entry in the 2, 1 position? The entry in the 2, 1 position would mean we're looking for row number 2. First value here is the row, and the second value is the column. So we're looking at second row, first column to come up with this entry, which is 5. The next thing we should understand is how to determine if two matrices are equal matrices. This just means if there exists two matrices, A and B, A is equal to B if and only if these two criteria are met. So they have to be of the same order, which means they have to have equal number of rows and columns. And then furthermore, every single entry must be the same. So let's see how we can use that information to solve for these variables in example number 1. So these two matrices are equal. Why? Because they're both 3 by 3. That means we're able to set what it means is our corresponding entries have to be equal in order for these two matrices to be equal. So in other words, what we can do now is we can set our 1, 1 entries equal to one another. We can set our, let's see what else we have. This is our 2, 3 entry. We can set that equal to the 2, 3 entry in this matrix. We could do, don't forget about the U, we could do 3 equals U or U equals 3. And then finally we could do 2Z, which is a 3, 1 entry, equal to this 3, 1 entry. So 2Z must be equal to 4. So again, we're able to do this because each of these matrices is of the same size, which means the corresponding entries must be the same. All right, so let's solve each one of these equations separately. So we get x equals 5 halves. We get y equals 7. U, we have already determined, that's 3. And z is equal to 2. The next thing we're going to look at is matrix addition and subtraction. All you have to do to add two matrices together is add their corresponding entries together. So I will show you that process. So it's going to be 4 plus 2, and then it's going to be 1 plus a negative 1. That's your first row. Your second row would be 2 plus 0, and then negative 3 plus 6. So your final result here of the sum of these two 2 by 2 matrices would be 6, 0, 2, 3. In this example, we're given a matrix A and we're given a matrix B, and we're asked to find A minus B. So to do that, we're going to rewrite matrix A. Put your subtraction symbol down there, minus. Write down, geez, I can't draw a 3. Write down your matrix B. And then what I like to do is the same thing we've always done when we have a subtraction operation occurring, and that is I'm going to add the opposite to every one of these entries in this matrix. So here's what's going to happen. Add the opposite, 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 opposite. And so now I'm going back to what we just did in example number 2. I'm going to add corresponding entries together. So 4 plus, well, the opposite of 0 is just 0. So 4 plus 0 is 4. Negative 1 plus negative 4 is negative 5. 0 plus 1 is 1. 4 plus a negative 3 is 1. Negative 3 plus negative 1 is negative 4. And finally, 8 plus negative 7 is 1. Scalar multiplication. What we're going to do now is this. If you see a coefficient, a number preceding the matrix, that's going to be an indication that you are going to be multiplying every one of these entries by this number. This is called a scalar. So in this case, the result would be as follows. Negative 3 times 4. At your first new entry, that product is negative 12. Then let's just go to the 2, 1 entry, this 1. So negative 3 times 1, negative 3. Negative 3 times 2 is negative 6. And finally, negative 3 times negative 3 is 9. Example number 5. Okay, so we're again given a matrix A and a matrix B, and now we're asked to find 2B minus 3A. So let's go ahead and write that out. So 2B would look like this. And then minus 3 times matrix A, which is this. All right, at this time, I'm going to perform the scalar multiplication on both of these matrices. So my first new matrix would be what? 2 times 0, that's 0. 2 times 4, that's 8. 2 times negative 1, negative 2. 2 times 3, that's 6. 2 times 1, that's 2. 2 times 7, that's 14. Again, because there's a negative here, I'm going to add the opposite. So I'm in essence going to be distributing this negative 3 through all 6 of these entries. All right? So negative 3 times 4, negative 12. Again, I'm not just doing 3 times 4 to give me 12. I'm making it negative 12 because I'm including the negative in the operation of scalar multiplication. All right, so let's continue. Negative 3 times negative 1 is 3. And then negative 3 times 0 is 0. Negative 3 times 4 is negative 12. And negative 3 times negative 3 is 9. Negative 3 times 8 is negative 24. And now we have to add corresponding entries to come up with our final result. So 0 plus negative 12, negative 12. Adding these two corresponding entries together, they're both in the 1, 2 position. 8 plus 3 is 11. And then negative 2 plus 0, that's negative 2. 6 plus negative 12, that's negative 6. 2 plus 9 is 11. And then 14 plus negative 24 is negative 10. Okay, the last thing we're going to be doing here in section 5.4 is solving a matrix equation. So we're given a matrix A, it's a 3 by 2 size, so is matrix B, 3 by 2. we're asked to solve for x based on this equation. All right, so our first move is going to be to solve this equation for x. So we end up getting this. All I did was I added 2a to both sides. Then I divided both sides of this entire equation by 2, which is the same as multiplying both sides of the equation by 1/2. So now we know x is equal to this. All right, well, based upon our given matrices, we can now come up with this value as a new matrix, matrix X. So we're going to do 1/2 times matrix B and then we're going to add matrix A to that. Three. All right, so what are we going to get here? Well, x will be equal to what? Let's go ahead and perform this scalar multiplication on this matrix. So 1/2 times -4 is going to give us a -2. 1/2 times -8 is -4. 1/2 times -2 is -1. 1/2 times 0, that's a challenging one, that's 0. 1/2 times 14 is 7. 1/2 times -6 is -3. Bringing down this matrix gives us that. And let's finish this thing. So we're going to, again, add corresponding entries. So -2 plus 0 is -2. -4 plus 3 is -1. -1 plus 2 is 1. 0 plus 0, that's the most challenging thing we've done thus far this semester. That's a 0. 7 plus -4, that's 3. And finally, -3 plus -1 is -4. So there is your new matrix X. Have a nice day.